Megawatts on your mind from LIGHTHIEF. We build it, we run it, we know what works, real projects, real returns. The renewable energy podcast that doesn't waste your time. Let's go.
This is LIGHTHIEF, and if you're listening to this, you either found the first episode mildly interesting or you clicked the wrong link. Either way, you're here now, so let's make the most of it. In the first episode, we talked about the state of renewable energy across Europe: solar, wind, biogas, the whole renewable ensemble. We mentioned that we'd be diving deeper into specific topics in future episodes. Well, the future has arrived rather quickly, and today we're going to talk about something that sounds spectacularly boring, but is actually quite important: operations and maintenance for photovoltaic farms. O&M, as the industry calls it, because apparently saying operations and maintenance every time is simply too exhausting. Now I realize that O&M doesn't exactly set the pulse racing. It's not as glamorous as unveiling a new solar farm with politicians cutting ribbons and promising to save the planet. It's not as exciting as watching massive wind turbines being installed by enormous cranes. O&M is what happens after the photographers have gone home, after the press release has been issued, after the investors have celebrated. It's the actual work of keeping a solar farm running efficiently for 25 years. And here's the thing: O&M is where your investment returns are made or lost. You can build the most beautiful solar farm in Europe with premium modules, top-tier inverters, perfect mounting structures, and flawless installation. But if the O&M is inadequate, that farm will underperform. Guaranteed. We've seen it happen. More times than I care to count, actually. So today, we're going to explore what O&M actually means for solar farms, where the term came from, what it involves, why it matters financially, and why so many people get it wrong. This is an introductory episode. We'll be covering the full landscape of O&M. In future episodes, we'll dive deeper into specific aspects: monitoring systems, cleaning strategies, warranty management, and all the other fascinating details that keep solar farms operating properly. Consider this your primer on why O&M isn't just someone occasionally checking if the panels are still there. Let's start with a slightly historical question. Where did this term operations and maintenance come from, and why do we use it? The concept of O&M didn't originate with renewable energy. It comes from traditional industrial and infrastructure management. Think power plants, factories, military equipment, aircraft. Any complex system that needs to operate reliably over long periods requires operations and maintenance. Operations refers to the ongoing running of the facility, monitoring performance, managing production, coordinating activities, handling the day-to-day business of keeping things working. Maintenance is exactly what it sounds like: the preventive and corrective work needed to keep equipment functioning properly. The term became standard in the power generation industry decades ago. Coal plants, gas plants, nuclear facilities, they all have O&M departments or contracts. When renewable energy started to scale up in the 2000s, particularly with wind and solar, the industry naturally adopted the same terminology. But here's what's interesting. The O&M requirements for a solar farm are completely different from those of a coal plant. A coal plant has rotating machinery, high temperatures, chemical processes, constant monitoring requirements. It's complex, dangerous, and requires highly specialized engineers on site constantly. A solar farm, by contrast, has no moving parts except for trackers if you've got them, operates at relatively safe voltages until you get to the inverter level, and doesn't require constant human presence. You'd think this would make O&M simpler, and in some ways it does, but in other ways it creates different challenges. The problem with solar O&M is that it's easy to do it badly. There's no immediate catastrophic failure if you skip maintenance for a few months. The panels keep producing, the inverters keep inverting, everything looks fine, but performance degrades slowly. A few percentage points here, a few more there. And over 25 years, those few percentage points represent enormous sums of money. This is why solar O&M developed as its own specialty within the renewable energy sector. In the early days, we're talking 2000s and early 2000s, many solar farm owners treated O&M as an afterthought. They'd have a local electrician check on things occasionally, or they'd rely on remote monitoring and hope nothing went wrong. Some of those early projects are still underperforming today because of inadequate O&M in their first decade of operation. The industry learned, slowly and sometimes painfully, that professional O&M matters. Not just having someone who can fix things when they break, but having systematic, proactive, data-driven maintenance programs. Asset management, not just equipment repair. Today, O&M is a professional sector within renewable energy. There are specialized O&M companies, we're one of them, that manage portfolios of hundreds of megawatts across multiple countries. There are international standards, best practices, performance benchmarks. It's become, dare I say it, rather sophisticated. But the fundamentals remain the same. Keep the equipment working properly, maximize energy production, minimize downtime, and do it all cost-effectively. Simple to state. Surprisingly complex to execute well. Right, so what does O&M for a solar farm actually involve? What are we talking about when we say we maintain a field of solar panels? Let me start by dispelling a common misconception. Solar panels are not maintenance-free. Yes, they have no moving parts. Yes, they're solid-state technology. Yes, they're designed to sit outside for 25 years. But low maintenance is not the same as no maintenance. And designed to last 25 years assumes proper care during those 25 years. Solar O&M encompasses everything required to keep a photovoltaic system producing at optimal levels throughout its operational lifetime. And that's more than you might think. At the highest level, you've got asset management. This is the strategic oversight of the entire installation. Performance tracking, financial management, regulatory compliance, stakeholder reporting. It's the coordination between all the various parties, the owner, the investors, the grid operator, the equipment suppliers, the insurance companies. Someone needs to be responsible for the overall health and performance of the asset. That's asset management. Then you've got the monitoring and analytics. Modern solar farms generate vast amounts of data. Every inverter reports its performance. String-level monitoring tells you what each section of the array is producing. Weather stations provide irradiation and temperature data. All of this needs to be collected, analyzed, and turned into actionable information. Is the farm performing as expected? If not, why not? Where are the problems? What needs attention? This sounds straightforward, but it's not. You need proper monitoring systems, properly configured. You need people who understand how to interpret the data. You need baselines and performance models. You need to distinguish between normal variations and actual problems. We've seen monitoring systems that generate hundreds of alarms per day, most of them meaningless, which causes operators to ignore them. And then when a real problem occurs, it gets lost in the noise. Then there's preventive maintenance. This is the scheduled, proactive work to prevent problems before they occur. Inspections, cleaning, testing, adjusting. Think of it like servicing your car. You change the oil before the engine seizes, not after. For solar farms, preventive maintenance includes things like infrared thermography to spot potential failures, electrical testing, torque checks on connections, cleaning panels, managing vegetation, inspecting mounting structures for corrosion or damage. Corrective maintenance is what happens when something actually breaks or fails. An inverter stops working, a string fails, a combiner box develops a fault, a cable gets damaged. Corrective maintenance is diagnosing the problem, getting the right parts, and fixing it quickly. The faster you can identify and repair faults, the less energy production you lose. There's also cleaning, panel washing. This deserves its own discussion, which we'll get to shortly, because it's more complicated and more important than many people realize. Vegetation management is another critical component. Plants grow. Shocking, I know. If you don't control vegetation around and under solar panels, you get shading, you get fire risk, you get problems. How you manage vegetation depends on location, climate, and site conditions. Mowing, chemical treatment, or in some cases, sheep. Yes, sheep. We'll come back to that. Then you've got warranty management and claims handling. Solar equipment comes with warranties, typically 25 years for modules, 5 to 10 years for inverters, various periods for other components. When something fails under warranty, someone needs to identify it, document it, submit the claim, chase the manufacturer, coordinate the replacement. This is administrative work, but it's important work. A warranty claim handled properly can save tens of thousands of euros. A warranty claim missed or mishandled costs that much. Documentation and reporting ties everything together, recording all maintenance activities, tracking costs, producing performance reports for owners and investors, maintaining compliance documentation for regulators and insurers. It sounds tedious because it is tedious. But try selling a solar farm without proper documentation, or try making an insurance claim without maintenance records. Suddenly, that tedious documentation becomes rather valuable. And finally, there's safety and compliance, health and safety procedures for anyone working on site, environmental compliance, grid code compliance, regulatory reporting, making sure the insurance remains valid, all the unglamorous administrative work that keeps a solar farm legally and safely operational. That's what O&M is. It's not one thing. It's a comprehensive program of monitoring, maintenance, administration, and management. Done well, it's invisible. The farm just works. Done badly, it's expensive and lost production, equipment failures, and reduced asset value. Let me make the case for why O&M actually matters, using the language investors understand: money. A typical solar farm has an expected operational lifetime of 25 to 30 years. Let's say 25 years for a nice round number. The business case for that solar farm, the financial model that justified the investment, assumes a certain level of energy production each year. That production figure multiplied by the electricity price gives you revenue. Subtract operating costs and debt service, and you get your return. Now, here's the thing about solar farms. The largest single operating cost is usually O&M, not the largest cost overall. That's the initial capital expenditure to build the thing. But once it's built, O&M is typically your biggest annual expense. Somewhere between 15,000 and 25,000 euros per megawatt per year is common, depending on location, technology, and what's included. For a 10 megawatt farm, that's 150,000 to 250,000 euros per year. Over 25 years, that's 3.75 to 6.25 million euros. That's a substantial sum. But here's what's more important: the impact of O&M quality on energy production. Let's take that same 10 megawatt farm. In a good location in Southern Europe, it might be expected to produce about 17,000 megawatt hours per year. At 50 euros per megawatt hour, a conservative figure, that's 850,000 euros in annual revenue. If poor O&M causes the farm to underperform by just 5%, you're losing 42,500 euros per year in revenue. Over 25 years, that's over €1 million. And 5% underperformance is actually quite modest. We've seen farms underperforming by 10%, 15%, even 20% due to inadequate O&M. Suddenly spending an extra 50,000 euros per year on proper O&M looks rather sensible, doesn't it? But it gets worse, or better, depending on your perspective. Poor O&M doesn't just reduce production in the short term. It accelerates degradation. Solar modules naturally degrade over time, typically losing about 0.5% of their capacity per year. But improper maintenance can accelerate this. Modules running hot because inverters aren't optimized. Modules affected by potential induced degradation because system grounding isn't maintained properly. Modules with microcracks from inadequate support or impact damage. This accelerated degradation compounds over time. By year 10, a well-maintained farm might be producing at 95% of its original capacity. A poorly maintained farm might be at 85%. By year 20, the gap is even wider. The financial impact is enormous. And then there's the impact on asset value. If you decide to sell your solar farm after 10 years, potential buyers will conduct technical due diligence. They'll review the O&M records. They'll look at actual performance versus expected performance. A farm with excellent O&M records and strong performance will command a premium price. A farm with patchy maintenance history and underperformance, the buyer will apply a significant discount, if they buy it at all. We've been involved in asset transactions where poor O&M history reduced the sale price by 10 to 15%. On a 10 million euro asset, that's $1 million to 1.5 million euros. All because someone tried to save money on maintenance. There's also the insurance angle. Insurance for solar farms is mandatory if you have project finance and advisable even if you don't. Insurers care about O&M. They want to see professional maintenance programs, safety procedures, regular inspections. Good O&M can reduce insurance premiums. Poor O&M can increase them, or in extreme cases, make the asset uninsurable. The point I'm making is this. O&M is not a cost center to be minimized. It's an investment in asset performance and value. Yes, you can do O&M cheaply. You can hire the lowest bidder, do minimal maintenance, hope nothing goes wrong. Some people do exactly that, and they regret it usually around year 5 when they realize their farm is consistently underperforming and they've voided half their warranties by not maintaining equipment properly. Professional O&M costs more upfront, but saves money overall. It's one of those rare situations where doing things properly is actually the economical choice. Let's dig into some specific aspects of O&M, starting with asset management and monitoring, because these are the foundation everything else builds on. Asset management is the strategic layer of O&M. It's the oversight function that ensures everything else happens properly. Someone needs to be responsible for the overall performance and health of the solar farm as a business asset. That's the asset manager. What does an asset manager actually do? They coordinate between all parties, the technical O&M team, the owner, investors, lenders, if there's project finance, the grid operator, equipment suppliers, insurers. They track financial performance against budget and forecasts. They ensure regulatory compliance. They manage contracts and relationships. They make strategic decisions about maintenance priorities and budget allocation. In smaller installations, the asset management might be handled by the owner directly. In larger projects or portfolios, it's often a dedicated role or even a separate company. We provide asset management services for farms we don't even do the technical O&M on because some owners want that strategic oversight independent of the hands-on maintenance work. Good asset management means problems get identified and addressed before they become expensive. It means maintenance budgets are allocated rationally. It means everyone involved knows what's happening and what's expected. Poor asset management means chaos, unexpected costs, miscommunication, reactive decision-making. Now, monitoring and analytics. This is where O&M has changed dramatically in the last decade thanks to technology. Every modern solar farm has a monitoring system. At minimum, this includes the inverters reporting their production. Better systems have string-level monitoring. Each string of panels reports separately, so you can identify problems at a much more granular level. Weather stations provide irradiation, temperature, and wind data. Some systems include soiling sensors to measure how dirty the panels are. All this data goes to a SCADA system, supervisory control and data acquisition, essentially a software platform that collects, stores, and displays the performance data. The SCADA system compares actual production to expected production based on weather conditions and historical performance. When actual production deviates significantly from expected, The system generates an alarm. This sounds excellent in theory. In practice, it depends entirely on how the system is configured and who's monitoring it. We've taken over O&M contracts where the SCADA system was generating 200 alarms per day. Most of them were false positives or minor issues that didn't require immediate action. The previous O&M team had simply learned to ignore the alarms, which meant when a real problem occurred, an inverter failure, a string fault, it got lost in the noise and wasn't addressed for days or weeks. Proper monitoring means configuring the system intelligently, setting appropriate alarm thresholds, filtering out noise, prioritizing alerts by severity, and most importantly, having someone competent actually reviewing the data regularly. We use a tiered alarm system. Critical alarms, things like inverter failures or significant production drops, require immediate response. Important alarms, like individual string underperformance, need to be addressed within 24 to 48 hours. Minor alarms, small deviations that might indicate developing issues, get reviewed weekly. This way, the O&M team focuses on what actually matters rather than drowning in alerts. The analytics side is equally important. It's not enough to know that production is below expected. You need to understand why. Is it weather-related, equipment failure, soiling, grid curtailment? Each cause requires a different response. Good monitoring systems include performance ratio calculations. This normalizes production for weather conditions so you can see true performance independent of whether it was sunny or cloudy. They track availability. What percentage of the time is equipment actually working? They calculate losses from various sources: soiling losses, thermal losses, DC losses, AC losses. This level of analysis requires proper software and people who understand how to use it. It's a combination of engineering knowledge and data analysis skills. We employ people specifically for this role. They're not electricians who fix things. They're analysts who interpret data and identify where the technical team needs to focus. The investment in proper monitoring and analytics pays for itself quickly. Finding a problem through data analysis before it causes significant production loss is far cheaper than discovering it during a routine inspection months later after you've lost thousands of euros in production. Right? Let's talk about preventive maintenance. This is the scheduled, proactive work that prevents problems before they occur. It's remarkably unsexy, but it's perhaps the most important aspect of O&M. The philosophy behind preventive maintenance is simple. It's cheaper to prevent failures than to fix them after they occur. For solar farms, this means regular inspections, testing, and maintenance activities on a defined schedule. A typical preventive maintenance program for a solar farm includes several components. Let's walk through them. First, visual inspections, someone actually walking through the site looking at things, checking for obvious problems, damaged panels, loose cables, vegetation growth, animal damage, evidence of water ingress, physical damage to equipment. You'd be amazed what you can find just by looking properly. We found bullet holes in panels from hunters, panels damaged by hail, cables chewed by rodents, inverters with wasp nests inside them. None of this shows up in your monitoring system until it causes a failure. Visual inspections should happen quarterly at minimum, monthly for higher performance contracts, more frequent for certain seasons, spring for vegetation issues, autumn for checking drainage before winter, after major storms to check for damage. Then there's infrared thermography. This uses thermal imaging cameras to identify hot spots in the solar array. A hot spot indicates a problem. Could be a failing cell, a bad connection, a cracked module, a string mismatch. These problems often aren't visible to the eye and don't always show up clearly in electrical monitoring, but they show up as heat. IR inspections should be done annually, ideally when irradiation is high so the panels are under load. We use drones with thermal cameras for larger sites, much faster and more thorough than ground-based inspection. The data gets analyzed, problem areas identified, and then you send a technician to investigate and fix the specific issues found. Electrical testing is another key component. This includes IV curve testing on strings to check their electrical characteristics, insulation resistance testing to ensure there's no current leakage, earth continuity testing to verify safety systems, verification of protection devices. This is proper electrical engineering work requiring qualified technicians and specialized equipment. For inverters, there's a separate maintenance schedule. Inverters are the only active electronic components in most solar farms, and they require attention. Filter cleaning or replacement, fan maintenance, cooling system checks, firmware updates, capacitor testing. Many inverter manufacturers specify maintenance requirements in their warranties. If you don't follow them, your warranty becomes void. So, this is both a performance issue and a contractual obligation. Trackers, if you have them, need mechanical maintenance, lubrication, motor testing, controller calibration, checking for structural issues. Trackers add performance, but they also add maintenance complexity. DC and AC electrical systems need periodic checks. Cable connections, especially in combiner boxes and junction boxes, need to be inspected for corrosion, tightness, and signs of overheating. We found loose connections that were causing kilowatts of losses simply because they'd gradually worked loose over time due to thermal cycling. Structural inspections are easy to forget but important. Are the mounting structures still sound? Any corrosion on the steel? Are the foundations stable? Any settlement or movement? A structural failure can damage dozens of panels and is expensive to repair. Better to catch problems early. The transformer and substation equipment require maintenance according to their own schedules. Oil testing for transformers, protection relay testing, switching equipment maintenance. This is specialized work usually done by electrical contractors rather than general O&M teams. And then there's documentation. Every maintenance activity needs to be recorded. What was done, when, by whom, what was found, what actions were taken. This documentation serves multiple purposes. It provides a maintenance history for the asset, it's evidence for warranty claims, it's required for insurance, and it helps identify patterns and recurring issues. The challenge with preventive maintenance is that it's easy to skimp on. If you skip a quarterly inspection, nothing immediately bad happens. If you delay an IR survey, the farm keeps producing. If you don't do that electrical testing, well, probably everything's fine, right? This is where professional O&M differs from amateur O&M. Professional O&M follows the preventive maintenance schedule even when it seems unnecessary, because that's exactly when it's most necessary, before problems become apparent. We track preventive maintenance compliance as a KPI. What percentage of scheduled activities were completed on time? For our contracts, we target 95% plus compliance. Sometimes weather or logistics prevent perfect compliance, but the schedule exists for a reason and should be followed as closely as possible. The return on investment for preventive maintenance is difficult to measure precisely because you're measuring things that didn't happen, failures that were prevented, but the data is clear. Farms with rigorous preventive maintenance have higher availability, better performance, and lower total maintenance costs over their lifetime than farms that take a reactive approach. Now, no matter how good your preventive maintenance is, things will break, equipment fails, components wear out, damage occurs. That's where corrective maintenance comes in, the repair work when something actually goes wrong. The key to effective corrective maintenance is speed and competence. The faster you can diagnose and repair a fault, the less production you lose. An inverter failure that's fixed in 24 hours costs you 1 day of production. The same failure that takes 2 weeks to fix because you didn't have spare parts or couldn't find a qualified technician costs you 14 days of production. This is why professional O&M contracts specify response times. Critical faults, things affecting more than 5% of plant capacity, typically require on-site response within 24 hours, major faults within 48 hours, minor faults within a week. These aren't arbitrary numbers. They're based on the economic impact of downtime. Diagnostic capability matters enormously. When something fails, you need to quickly identify what failed and why. Is it a module problem, string issue, combiner box fault, inverter failure, AC collection system problem? Modern monitoring helps, but it still requires someone who understands how solar systems work and can interpret the symptoms. We've been called in to fix problems at farms where the previous O and M providers spent weeks replacing random components because they couldn't properly diagnose the actual fault. This is expensive and ineffective. Proper training and experience make a huge difference. Spare parts management is another critical aspect. You need to have critical spares available, at least locally, if not on site. Common failure items like inverter boards, fuses, contactors, DC connectors. Having these in stock means you can fix problems immediately rather than waiting for parts to be shipped. But spare parts are also expensive to keep in stock. Too many spares, and you've tied up capital unnecessarily. Too few, and you have extended downtime when something fails. Professional O&M providers optimize spare parts inventory based on failure rate data and supplier lead times. Then there's the question of who does the repair work. For minor issues, the O&M team can handle it directly. For complex problems, you might need specialized contractors. For warranty repairs, the manufacturer might need to be involved. Coordinating all this requires experience and good relationships with suppliers and contractors. Warranty coordination deserves special mention. When equipment fails under warranty, the manufacturer should replace or repair it at no cost. But warranties have conditions: proper installation, proper maintenance, proper operating conditions. If you can't demonstrate that equipment was maintained according to manufacturer specifications, your warranty claim can be rejected. This is why maintenance documentation matters. We've successfully claimed warranties on inverters that failed because we could provide complete maintenance records showing the units were serviced properly. We've also seen warranty claims rejected because maintenance records were inadequate or missing. Warranty claims also take time. Submit the claim, manufacturer reviews it, sends a technician or asks for more information, approves the claim, ships replacement parts, schedules repair. This can take weeks or months. Meanwhile, you've got failed equipment and lost production. This is where having good spare parts inventory helps. You can fix the problem immediately and settle the warranty claim afterward. The economics of corrective maintenance are straightforward. Minimize downtime, repair things properly so they don't fail again, and claim warranties whenever possible. Every day of equipment downtime costs money in lost production. Quick, effective repairs minimize those costs. Let's talk about something that sounds simple, but is actually rather more complicated. Cleaning solar panels. Solar panels get dirty. Dust, pollen, bird droppings, agricultural residue, industrial pollution, snow in winter. This soiling reduces light transmission through the glass, which reduces power production. The question is, how much does soiling affect performance? How often should you clean, and what's the optimal cleaning method? The answer, as with most things in solar O&M, is it depends. Soiling rates vary enormously by location. A farm near the coast gets sea salt spray. A farm near agricultural land gets dust and pollen. A farm near industrial areas gets pollution. A farm in a high-traffic area gets vehicle emissions. Each type of soiling behaves differently. In some locations, like Northern Europe with regular rainfall, natural cleaning from rain is often sufficient. The rain washes away most dust and dirt, and manual cleaning might only be needed once or twice per year, if at all. We have farms in Poland where we barely clean the panels because the weather does it for us. In drier climates, southern Spain, Cyprus, parts of Italy in summer, soiling can be severe. Without rain for months, dust accumulates continuously. In these locations, you might need to clean every 4 to 6 weeks during dry periods to maintain performance. The performance impact of soiling also varies. Light dust might reduce output by 2 to 3%. Heavy soiling can reduce it by 10%, 15%, even 20% in extreme cases. The economic calculation is simple. If cleaning costs 50 euros per megawatt and restores 5% production, and 5% of monthly production is worth 400 euros, then cleaning is economically justified. If 5% is only worth 100 euros, it's not. This is why soiling monitoring is valuable. Some farms have soiling stations, reference cells that accumulate dirt at the same rate as the panels, allowing you to measure soiling impact precisely. Without this, you're making educated guesses about when cleaning is needed. Cleaning methods matter. There are several approaches. Manual cleaning with brushes and deionized water is the most common. Teams of workers with brushes on poles, usually early morning or late evening to avoid thermal stress on hot panels. Labor-intensive but effective. Cost varies by location. Cheaper in countries with lower labor costs. Automated cleaning systems exist. Robots or fixed brush systems that travel along the panel rows. Higher capital cost but lower operating cost for large installations. We've used these on some projects, particularly in desert conditions where soiling is severe and consistent. Waterless cleaning methods are developing, special coatings or treatments that reduce soiling adhesion or dry brushing techniques. These are useful in water-scarce locations, but generally less effective than wet cleaning. There's also the question of water quality. Cleaning with hard water can leave mineral deposits that are worse than the dirt you're removing. Deionized or softened water is preferable but more expensive. In some locations, water availability is a constraint. You can't clean frequently because there isn't enough water. Then there's the issue of panel coatings. Some premium modules have anti-soiling coatings that reduce dirt adhesion. These work to an extent, but they still need cleaning, just less frequently. The coating effectiveness also degrades over time. One creative solution we've seen is using sheep for vegetation management under the panels. This serves double duty. The sheep keep the grass down, which reduces fire risk and eliminates mowing costs, and they also reduce dust generation from bare soil. In some Italian projects, we've worked with local farmers who graze sheep under the panels. The farmer gets free grazing, the farm gets free grass management, and everyone's happy. The sheep don't clean the panels, obviously, but they help reduce soiling by controlling dust. The key point about cleaning is that it needs to be economically optimized. Clean too often and you waste money on unnecessary cleaning. Clean too rarely and you lose production from soiling. The optimal frequency depends on soiling rate, cleaning cost, electricity revenue, and whether you have rainfall doing free cleaning for you. Professional O&M includes monitoring soiling impact and adjusting cleaning frequency accordingly. Amateur O&M either never cleans or cleans on an arbitrary schedule regardless of actual need. Neither approach is optimal. Vegetation management sounds trivial until you realize that plants are remarkably persistent and surprisingly problematic for solar farms. The issue is straightforward. Plants grow. If you don't control them, they shade panels, reducing production. They create fire risk in dry seasons. They can damage equipment, roots undermining foundations, vines growing into junction boxes, vegetation blocking drainage, and they make the site difficult to access for maintenance. The traditional solution is mowing. You cut the grass repeatedly throughout the growing season. Simple, effective, and expensive. For a 10-hectare solar farm, you might need to mow 6 to 8 times per year, depending on climate. That's labor, equipment, fuel, and time. In some locations, chemical vegetation control is an option. Herbicides that suppress growth. This reduces mowing frequency but raises environmental concerns. Many owners prefer to avoid chemicals for environmental or regulatory reasons. And in some locations, herbicide use near solar installations is restricted or prohibited. Then there are physical barriers, geotextile membranes or gravel covering the ground to prevent growth. These work, but are expensive to install and not practical for all sites, particularly large, irregular terrain. The sheep solution I mentioned earlier is genuinely elegant where it works. The sheep graze continuously, keeping vegetation short without needing mowing equipment. They're particularly good around panel supports and in areas difficult to mow. They don't eat everything. You'll still need some supplemental mowing, but they reduce the work significantly. We've also seen goats used, though they're trickier. Goats climb on things, which is entertaining but problematic when the things they climb on are your solar panels. Sheep are more sensible about this. The other consideration with vegetation is what you plant in the first place. Some farms are establishing native meadows or pollinator-friendly plants deliberately. These might require less maintenance than grass, provide environmental benefits, and create better optics for community relations. The solar farm becomes a habitat enhancement rather than just an industrial installation. But whatever approach you take, vegetation management requires ongoing attention. It's seasonal, intense in spring and summer, minimal in winter in most European climates. It requires planning. You can't decide to mow the day you notice the grass is 2 feet high. You need scheduled programs. The cost of vegetation management is often underestimated in initial project budgets. It's not a huge expense individually, but it's persistent. Every year for 25 years, it adds up. Budget properly for it, and select the management method that makes sense for your specific site. Section 9. Warranties and documentation. The paperwork matters. 6 to 8 minutes. Let's discuss something even less exciting than cleaning panels. Warranties and documentation. I can feel your enthusiasm from here, but bear with me, because this is where significant money can be saved or lost. Solar equipment comes with substantial warranties. Module manufacturers typically provide 25-year performance warranties, guaranteeing that panels will still produce at least 80% of their original capacity after 25 years. They also provide product warranties against manufacturing defects, usually 10 to 15 years. Inverter warranties are shorter, typically 5 to 10 years on the equipment warranty, with extended warranties available for purchase. Other components, mounting structures, cables, trackers, have their own warranty terms. These warranties represent significant value. If a module fails in year 3, that's a several €100 replacement that should be covered under warranty. If an inverter fails in year 6, that's potentially tens of thousands of euros in replacement cost. But, and this is crucial, warranties have conditions. They require proper installation, proper operation, and crucially, proper maintenance. If you can't demonstrate that equipment was maintained according to manufacturer's specifications, your warranty claim can be rejected. This is where documentation becomes critical. Every maintenance activity, every inspection, every test, every cleaning, it should be documented with date, details, and who performed the work. This maintenance log becomes your evidence that you've upheld your side of the warranty agreement. We maintain detailed digital maintenance records for all our contracts. When we need to make a warranty claim, we can provide complete documentation showing exactly how that equipment was maintained. This dramatically improves claim success rates. The warranty claim process itself requires careful management. You identify a failure, document the symptoms and circumstances, contact the manufacturer, provide evidence, follow their diagnostic process, submit formal claim, wait for approval, coordinate replacement, install new equipment, dispose of failed equipment properly. This can take weeks or months. Some manufacturers are responsive and helpful. Others are less so. Having experience with different manufacturers and established relationships helps considerably. There's also the question of warranty aggregation. If you have multiple solar farms with the same equipment, you might see pattern failures, a particular inverter model that fails frequently, or modules showing similar defects. Documenting these patterns and pursuing manufacturer responsibility as a systemic issue rather than individual claims can sometimes lead to better outcomes. Extended warranties are another consideration. Many equipment suppliers offer extended warranty periods for additional cost. Are they worth it? Depends on equipment reliability, the cost of the extension, and the likely failure rate. For inverters, extended warranties often make sense because failure rates increase after the standard warranty expires, and replacement costs are high. For modules, the economic case is less clear because module failure rates are generally low. The documentation extends beyond just warranty management. Compliance documentation is required for various purposes. Insurance companies want maintenance records, lenders want performance reports, regulators want safety documentation, tax authorities want operational records. Good O&M includes systematic documentation and reporting. Monthly performance reports, quarterly maintenance summaries, annual compliance documentation. This seems bureaucratic and tedious until you need to sell the asset, refinance debt, or prove compliance after an incident. Then suddenly those meticulous records are valuable. Let me illustrate the importance of O&M by describing what happens when it's done badly. We've seen this multiple times when taking over contracts from inadequate O&M providers. Scenario 1, the monitoring was in place, but no one was really watching it. Alarms were ignored. A string failure occurred, maybe 20 panels, not enough to be obvious in total production. The failure went unnoticed for 4 months. That's 4 months of lost production from those panels, probably 1,500 to 2,000 euros in lost revenue. But worse, the root cause was a bad connection that was creating heat. By the time it was discovered, the connector had damaged the cable, requiring additional repair work. A problem that could have been fixed in an hour for 50 euros became a repair costing several hundred euros plus 4 months of lost production. Scenario 2, panel cleaning was neglected in a location with high soiling rates. Production degraded slowly over 18 months, down about 12% from expected. No one noticed because there wasn't a proper performance baseline being tracked. When we took over the contract and did analysis, we discovered the underperformance. After a thorough cleaning, production jumped back up. But that's 18 months of lost revenue that could have been avoided with proper cleaning protocols. For a 10 megawatt farm, 12% production loss for 18 months is roughly 100,000 euros in lost revenue. Scenario 3, preventive maintenance was skipped to save costs. Electrical inspections weren't done. IR surveys weren't performed. After 3 years, multiple problems had accumulated. Loose connections, failing bypass diodes, several modules with internal failures. The farm was underperforming by 8 to 10%. Correcting all the accumulated problems required a comprehensive remediation program costing over 150,000 euros. Had proper preventive maintenance been performed, most of these problems would have been caught early and fixed incrementally for a fraction of the cost. Scenario 4, no spare parts inventory, no service contracts with suppliers. An inverter fails catastrophically. The O&M provider has to order a replacement, which takes 8 weeks to arrive due to supply chain constraints. Then they can't find a qualified technician to install it for another 2 weeks. Total downtime, 10 weeks. For a 1 megawatt inverter in summer, that's roughly 40,000 euros in lost production. A proper O&M provider would have had spare parts or fast-track arrangements with suppliers, limiting downtime to days rather than weeks. Scenario 5, warranty management was neglected. Multiple modules showed failures over a 5-year period. These should have been claimed under warranty, but the O&M provider didn't document them properly or didn't pursue the claims. By the time the farm owner realized this, some failures were beyond the warranty claim period. The farm owner absorbed costs that should have been covered by manufacturer warranties. Estimated loss, over 50,000 euros in replacement costs. The pattern in all these scenarios is the same. Inadequate O&M causes performance degradation and increased costs that far exceed any savings from cheap O&M. The farm owners thought they were saving money by choosing low-cost O&M. Actually, they were losing money significantly. This is why professional O&M matters. Yes, it costs more, but it prevents these expensive problems. And over 25 years, proper O&M is dramatically more economical than cheap O&M. Right, let's wrap this up. We've covered what O&M means for solar farms: asset management, monitoring, preventive maintenance, corrective maintenance, cleaning, vegetation management, warranty handling, documentation. We've discussed why it matters financially and what happens when it's done badly. But this is just the overview. Each of these topics deserves deeper exploration, which is exactly what we'll do in future episodes. We'll have episodes dedicated to monitoring and diagnostics, how to actually interpret performance data, how to configure SCADA systems properly, how to identify problems from data before they become obvious. We'll discuss cleaning in more detail, regional variations, optimal frequencies, cost-benefit analysis, emerging technologies. We'll explore preventive maintenance programs, how to design them, how to execute them, what to prioritize. We'll talk about spare parts management and corrective maintenance strategies. We'll get into the business side, contract structures for O&M, how to evaluate O&M providers, what to include in O&M agreements. And we'll discuss O&M across different European markets, because what works in Spain doesn't necessarily work in Poland, and regulations vary considerably. The point of today's episode was to establish that O&M is not optional, not trivial, and not something you can afford to do casually if you want your solar farm to perform well over its lifetime. If you're an investor, don't underestimate O&M costs in your financial model, and don't accept the lowest bidder without scrutinizing what you're actually getting. Cheap O&M is expensive in the long run, and if you're a developer, think about O&M during the design phase. Design for maintainability, choose equipment with good support, plan access routes, budget realistically for ongoing operations. If you're an owner, treat O&M as the critical ongoing investment it is, not as a cost to be minimized. Solar farms are 25-year investments. O&M is what protects that investment. Done well, it's invisible. The farm just works. Done badly, it's expensive and obvious. This is LIGHTHIEF, reminding you that operations and maintenance is where the theory meets reality in renewable energy. We'll be back to discuss more aspects of keeping solar farms running properly. Until next time, may your panels stay clean, your inverters stay cool, and your performance ratio stay high. An energy podcast that doesn't waste your time. Let's go.